In archery, there's something called the archer's paradox. Basically, when an archer shoots, they must aim slightly off target in order for the arrow to fly straight. This happens because the arrow actually oscillates while it flies. It vibrates right to left, and when it is first released, the oscillation causes it to curve around the bow and start to fly straight. This frequency of the vibrations must be perfectly in time for the arrow to fly straight. If it is too slow, it could hit the bow and fly off course, and too fast would cause the arrow to not straighten out in time. The draw length, the draw force of the bow, as well as the shooting technique of the archer and the stiffness of the arrow all affect the oscillation of the arrow, and everything must be in sync for this paradox to work. Let's say an arrow making company wanted to customize their arrows for a customer, or an archer wanted to analyze their shots to make it better. A good way to improve the arrows or the shots would be to analyze the frequency the arrow oscillated at when the archer shot. The archery company would know whether or not to make their arrows more rigid or less, and the archer would know how far back they should draw. The problem here is that the arrow moves so fast that one can only see the oscillation using a high-speed camera. A solution to this would be to create something that could measure the frequency of the oscillations without needing a fancy camera. My invention would be sensors laced all throughout the arrow that could measure the frequency, and a device that, when the data is plugged in, will give the archer or whoever is using it feedback. The sensors would be throughout the arrow, in the nock, fletching, main shaft, and the endpoint. At the end of the shot, the data would be collected in either the detachable nock or fletching, as well as the endpoint. Once the archer retrieves their arrow, they could either 1. Remove the fletching that stores the data and plug that into the device, 2. Remove the nock that stores the data and plug that into the device, or 3. Keep it all intact and just plug the endpoint into the device. The device, around the size of an iPhone 6 Plus, would tell you the information, the frequency of the arrow, and then the person who needs this data will be able to use it to their advantage, which would be either improving the making of an arrow or improving shooting. These sensors would use electromagnetic waves to measure the frequency. Additionally, archers often use a thing called a clicker. This is placed on their bow and makes a clicking sound once they have pulled back the string far enough, and the click sound tells the archer when to shoot. However, an archer needs to set up the clicker on the right spot, and a new archer just learning where to place their clicker would be able to use this invention to determine how far back they need to draw, therefore also figuring out where to place their clicker.